world. Welcome again to my YT channel. Now we have done discussing the theory and concept for thermodynamics. Now we go to problem solving. So we have example here. Okay, this is an example of problem solving, and let's see what law of thermodynamics must be used here. So we have the zero law, the first law, the second law, and the third law of thermodynamics. And we must apply now. Or whether what kind of thermodynamic processes is this? Okay, thermodynamics process. Okay, so right now. So 2,500 joules of heat energy was removed from a gas. The gas was compressed at a constant pressure of 3 atmosphere from 25 liters to 15 liters. How much work was performed by the gas? Calculate the change in the internal energy of the system. So it's very clear in the problem that uh, talking about the work, the heat, and the internal energy relationship. Okay. So if talking about the internal energy, work, and its relationship, this is first law of thermodynamics. And now we will obtain the formula of first law of thermodynamics. Okay, we have solution. We have heat is equals to, okay, delta change in internal energy, change in internal energy, in internal energy plus work. So this is our equation to be used. Heat is equals to the change of internal energy plus work. And then Q is equals to delta U plus work, like this. And now we substitute values now. Okay, the heat energy was removed, meaning negative, because heat is being removed, that is negative. Heat is being added is positive, but heat here was being removed, so Q is equals to negative 2,500 joules. So from a gas, the gas was compressed at a constant pressure of 3 atmosphere. So we have the pressure of 3 atmosphere, okay, from 25 liters to 15 liters. Okay, like that. So we have uh, volume, volume initial is 25 liters, and then volume final is 15 liters. Okay, this one is given. Volume initial is 25 liters, and volume final is, since one 20 15 liters. Okay, now we substitute values, but before we will substitute these values, guys, we need to convert first liters to cubic meter in metric system, right? Okay, so we have conversion. So 25 liters, okay, 1 liter is equals to 1,000 cubic centimeter. 100 centimeter is equals to 1 liter raised to the power 3. So we have here cubic meter, cancels out, cancels out, cancels out. Okay, we need to convert first the 25 liters into cubic meter. Okay, so that it will agree in the metric system, because sorry, joules is Newton meter man siya. Okay, so calculator. So So this 0.025 cubic meter, which is our V initial, this one. So, okay, the 25 liter is equals to 0.025 cubic meter. That is our initial volume. Our final volume is 15 liters. So this is equal to 15 times 0.05. So our final volume is 0.015 cubic meter. Okay? The same process with how to convert 25 liters. Okay? Like that. Now using the Q is equals to delta U plus W. So we have the heat, we don't have the internal energy, and we don't have also the work. We have the heat, we have the internal energy, and we don't have also the work. And then in A as work is being asked, and in B internal energy is being asked. Okay. Work and internal energy is being asked. Okay, are being asked. So we need to have one more formula to solve the equation, right? So work is equals to, from the first law of thermodynamics also, work is equals to pressure times the change in the volume. Since we have the change in the volume from compressing it from 15 liters to 15 liters, then we can solve now for work. Work is equals to, the pressure is mentioned also. Pressure is equals to 3 atmosphere. So 3 atmosphere, okay, times volume final, which is 0.025 cubic meter minus 0.015 cubic meter. So this is our work now. 3 atmosphere, close open parenthesis, 0.025 cubic meter minus 0.015 cubic meter. But the problem is atmosphere will not agree with the metric system, which is the Newton per square meter for the unit of pressure. So we need to convert first 3 atmosphere to Pascal. Okay, so here pressure, 3 atmosphere, 1 atmosphere is equals to 101 325 Pascal. This one. 3 atmosphere, 1 atmosphere is 101,325 Pascal. So calculator, so we have pressure is 303,975 Pascal or Newton. So this is our pressure to be substituted in the equation now. 3,000, okay, no, 303,975 is our Pascal, and Pascal is equivalent to Newton per square meter. Okay, so substitute these values here. Okay, so we have the 303,975 Newton square meter, and 0.025 minus 0.5, so 0.01 cubic meter cancels, so the unit will be in Newton meter or in joules. Okay, so 0.025 minus 0.015 is equals to times 303,975 is equals to 3,000 309.75 joules. The answer is 3,000. Okay, here 3,039.75 joules is the answer. Okay, like that. Since that is our work, we answered already the first, which is 3,039.75 joules. How about the delta U? So to compute with the delta U, here we can obtain delta U as delta U is equals to uh, Q minus W. Okay, wait that. Yes, delta U is equals to Q minus W, and heat energy. All heat energy is being mentioned here, which is heat is negative 2,500 joules. In this equation, delta U, Q minus W, substitute the Q here, negative 2,500 joules, negative 2,500 joules minus the work, which is 3,093.75. Okay, like that. Okay, so let's read. So our answer is but take note, class, so it should not be all negative. Ah, so all negative. We need also to think if it's all negative, something wrong with our equation here at the bottom for the work. Let's review. Okay, so pressure times change in volume. So final volume minus initial volume. So this is reverse. This is 0.015 minus 0.025. And it is so negative. So our work is negative 3,039.75. Okay? Because if we substitute this positive 3,039.75 in this equation here, so we will obtain a negative internal energy. But calculate the change in internal energy of the system. It should be positive man siya. Okay? So, Q, ang heat nato is negative. Ano? Negative siya. And then atong work is negative also. So, minus like this. So, it could be, this is positive already, ha? So, 2, 5, minus 3,093.75 is equals to 593.75 joules. Our work. Okay? So, work is, delta U is 593.75 joules. Our work is negative and our internal energy is positive. Okay. So our answer is 593.75 joules is our internal energy, change in internal energy, and our work will be negative 3,093.75 joules. Okay, now we will try to look at the problem. Okay, heat energy was removed meaning negative ang heat, so that's why negative heat by the theory, ha? And then how much work was performed by the gas man siya. So how much work performed by the gas then it is positive. Okay, so work, okay, like this, by the gas, how much work was performed by the gas? Sorry, negative. Okay, on the gas is positive. Okay, calculation the internal energy of the system. Okay, for the heat is being removed is negative. Heat is being added is positive. For the work done by the system is negative. Okay, work done on the system is positive. So this was negative, right? Work is negative here. Okay, so in this problem, be careful with the sign. plus and minus sign because it matters a lot for the work, for the heat, and then the internal energy. So you just review if you think the answer is very big, and then if the answer is negative, though the quantity don't have to be negative, then you go back to your solution, something like this. It's wrong because it defeats the theory and concepts and principles. Okay, thank you so much for watching this live streaming and vlogging. So be careful with the sign, just like me. And then also for the final change in the volume, initial change in volume, then you will interchange that one. So the sign will also be wrong when you compare that to the problem, because you will take note that if heat is being added, that is heat is being removed, heat is being added, is being removed, like this. Remove negative, added is positive, and work done by the system is negative, work done on the system is positive, something like that. Okay, thank you so much for watching. God bless everybody.